In this lesson, we're going to be talking about periodic functions and their properties. We're going to be starting a new unit here where we investigate periodic functions, and more specifically something called sinusoidal functions, which are a type of periodic function. All right, so let's just go through some definitions, and if you prefer, a lot of the stuff you can go read in the textbook on your own, but I'll walk you through it too. All right, so first, what is a periodic function? Well, a function whose graph repeats at regular intervals. So something that repeats over and over and over again. So these ones you can see on the screen we have up right now are periodic graphs because they're repeating a pattern over and over and over again. So let's be specific though. When we talk about repeating at regular intervals, the y value is where we see that repetitive pattern, okay? As the x value changes at the same increment. So your x's, let's just say you're increasing, 1, 2, 3, 4. So I'm going to make a little table here actually over at the side showing an example, just looking at the x and y coordinates. So let's just say we have our x's going 0, 1, 2, 3, 4, as long as there's some sort of regular interval, or 5, 10, 15, 20, whatever. Let's do a periodic pattern as long as it repeats something. So let's just go 1, 2, 3. 1, 2, 3. Right? Or let's say the x's kept going 6, 7, 8. 1, 2, 3. This is a repeating pattern over and over and over again. So we need to look for some repetition. So that would be a periodic function. All right, now, what is the period? Well, a period is defined as basically a length of time, right? And a lot of our periodic functions deal with time. On our graphs, the period is how long does it take to do one cycle. Okay, so if we're talking about time, if this was a graph about time, this is a graph of a wheel spinning, how many minutes maybe it takes or seconds for that wheel to spin. So that would be one period. So one cycle is one instance of that graph. Okay, and then we repeat that cycle over and over and over again. And the length basically of your x coordinates, okay? So over here, the definition of a period right here, right? It's the change in the independent, usually our x value, right? What does it take? So like, let's say this is 0 and this is 1, 2, 3, 4, 5. Let's say that's 6 right there. So we'd say the period is, let's say this was time 6 seconds or 6 units. Okay, so that's the period. Okay, trough and peak. Those are just fancy words for basically saying the minimum and the maximum. And when we say that, we're talking about the y coordinate in both of these, okay? So what is our minimum? What's the lowest and what's the highest it goes? So in this case, let's just say that's 1, 2. The peak would be 2 and the trough would be at -2, it looks like. All right, and they show you here on some more graphs. So again, I just kind of took a lot of this stuff from your textbook. You can read it through, but I thought I'd explain a lot of it too because there's a few other interesting things that I want to cover. Okay, so I've just moved it down a little bit to look at example 1. Again, from your textbook. So in this scenario, they're saying there's some machine and it's used to cut metal into 6-meter strips. And the graph over here shows that, that graph, right? Okay, so let's see what's happening here. So there's some machine, if we can imagine a factory, some strips keep coming through on some machine and something comes down and cuts them, right? And then the next one comes along and then it comes down and cuts them. That diagram clearly does not match anyway what I'm talking about. So let's just imagine some sort of blade drops down and cuts the metal as the metal keeps coming through the machine. All right, so let's take a look at it here. They want us to identify, let's start with the period. What is the period of this function? Okay, so let's follow it. So it starts here, starts here, goes along, it's waiting. See, nothing's happening. It's not going up, it's not going down. This is the height, right? How high up is this blade, the cutting blade, right? How high is it? So it's just sitting there at 0.5 centimeter in the air, right? It's just sitting, and this is time, 1 second, 2 seconds, 3 seconds. So, 1 second goes by, 2 seconds go by, 3 seconds go by, and then the blade comes down and then back up. And that would be one period. So that's really sloppy, but that would be one period or one cycle. Now, one cycle of the graph, the period is how long is that? That's our x value. So from here to here, right? From 0 to 4 seconds. So our period would be 4 seconds. And we want to try to include the units on any kind of real world examples here. All right, and then it repeats, right? It just does the same thing again. This is a second cycle, right? And it takes another 4 seconds because it ends at 8, and so on and so forth. And it keeps going. So it's a periodic function, okay? All right, let's get rid of this stuff. Now it says next thing, what is the trough? So what's the lowest the y value is? Well, the lowest it goes is the blade comes all the way down to a height of 0. So 0 what? Units are centimeters. Again, now we're talking about the y coordinates. What's the peak? What's the highest the blade goes? Only half a centimeter high. So there's your peak and trough, right? The highest it goes, the lowest it goes. All right. What else do we have to talk about here? Just some general graph reading skills here. This question says, how long does the blade stop for in each cycle? So how long does it stop for? Well, between here and here, the blade is stopped. It's not doing anything. It's not going up. It's not going down. All the movement's happening from here to here, right? That's when it's dropping and coming back up. So it's stopped for 3 seconds of each cycle, right? So 3.0 seconds. All right. How long does it take for the blade to go down and come back up? Well, that would be the V part of it here, right? This is where it's going down, coming back up again. We're just reading a graph, pretty basic stuff. So between 3 and 4 seconds from here to here, right? So 1 second. All right. All right, and the final question for the first kind of warm-up example here says, let me just get my eraser. There we go. Based on the graph, when will the blade strike the cutting surface again? Okay, so let's think this through here. When does it hit? The first time it hits is at 3.5 seconds, right, on our graph. So that's the first time. When's the second time it's going to hit? Well, right here at 7.5 seconds. Now, anything in a periodic function will occur again, right? It repeats. So the distance between any occurrence of something in a periodic function and its next occurrence will always be the period, because the period is how long it takes for one cycle. So how long does it take you to get back to that place again? So notice our period is 4 seconds, right? Well, it takes 4 seconds. You're adding 4 seconds to go from there to there. So the next time anything will occur again will be the exact same, just add the period and you can find it, right? So 7.5 plus 4, what are we going to get? 11.5 seconds. And we could do this all day, obviously, right? If we want to know the next one, we could add another 4 and we get 15.5 seconds. And so on and so on and so on. So any point. So if I want to know when is this point going to happen again, right? I would just add 4 seconds. It would be right here, right? So at 1 plus 4 is 5, right? So anything, just add the period to it, which everyone's probably going, yeah, no kidding. I know that. But then we start doing some of these questions and we forget all we got to do is add the period to find when we get back to the start. So if you're talking about a wheel spinning, like we're going to look below, when does it arrive at the top again or arrive at the bottom again? Just add the period to whatever time you have now, and then you'll get that. All right, so let's just say the next time it occurs is 11.5 seconds. Okay, let's move down the page and just look at a little bit more here. Okay, let's look at example 2, and while we do that, we'll talk about a couple more definitions, just keywords and things we need to know. Nothing really complex to so far. It's just really knowing the basics and understanding this stuff. And if you're wondering, for those of you who've taken physics, a lot of this should sound familiar because studying periodic functions and what we're going to study later called sinusoidal functions are really important in physics. Again, physics being applied mathematics. And these kind of periodic functions model things that repeat, right? So you can think of different things in your physics class repeat, especially the spinning of a wheel is a really big one. As you spin a wheel around and around, it makes the same graph. And that's exactly what we're going to look at right here is a spinning wheel. So the textbook just kind of continues the idea from example 1. You got this metal that's been cut now. And then they take this metal and they're going to wind it around into a circle. They're going to wind it around. It looks like a cylinder, right? So there's a rotating cylinder, and we're going to wind this metal around it. So the graph shows the height of the end of one of the strips as it spins around the cylinder. So it's going around and around. So any spinning wheel has this exact same graph, this smooth wave, right? And that's what we call it, waves. So some of you who've done physics have seen sinusoidal waves, sine waves. And they model a lot of different things in the real world, and most importantly for now, wheels. Okay, so any wheel that spins always produces the same graph. Now maybe the graph's more stretched out, maybe it's higher, maybe it's lower, things like that, but it's always the same graph. All right, so let's start with the basics that we already covered. The trough, what's the lowest we go, and the peak, what's the highest our y values are. So our trough, it looks like we're at 1 millimeter. Again, include your units, right? And we are at a peak of 9 millimeters. All right, so our range is just remember our range is just our y values. That's all it is. So they want us to give us what could all our possible y values be. So now if I want to write it out the really fancy way, I'll do that because we haven't done that in a while, right? The proper way of doing it is we write, all right, what can y be? And, oh, we're not even using y, right? In this case, what's y replaced by? H for height. All right, so we're going to do height belongs to the real numbers such that, now a lot of times we exclude this just because we want to get to the condition. The condition is the thing we're really interested in. What's the lowest it can go and what's the highest it can go? So I'm going to say it's between 1 and 9. There you go. So again, when you do your work for me, the main thing is we're looking for this condition here, okay? That's what we really want for our answer. I don't mind if you leave this part out because we understand at this point. Now, if it's something really important, of course we want to include it, but for me, we're good for now. So height can be any real number between 1 and 9. That's our range, right? Now the x values, if this thing spins forever, which obviously in the real world it can't, but if it spins forever, x could be anything greater than 0, right? Time starts at 0, and away we go. All right, so the main thing here, let's talk about the equation of the axis and the amplitude. So I just want to extend my, right, I've got my top of my wheel here, and I've drawn a wheel next to the graph, and I've got the low point of my wheel here, right? And then we'll just label that there's 9 and 1. Just doing kind of a little rough sketch here. Now think about the middle of this graph, right? Let's talk about the middle. And let's label that, right? Where's the halfway point of that? Well, to find that, now, and this one's pretty easy, the halfway between 1 and 9, but let's say it's more complex or ugly numbers or whatever. They call this the equation of the axis. That's this guy right here. And its formula is pretty easy. You're literally just saying what's the maximum plus the minimum divided by 2. So in our case, I'll just do it down here in this box. Our maximum, so we're going to say h for this instead of y. They're using y, right? Because it's the dependent value. But we're using h for height. What's the maximum? What's the minimum? Add them together. 9 plus 1, that's 10, divided by 2. The equation of our axis is a horizontal line of h equals, oops, I was going to write 2. H equals 5, okay? So the equation of the axis is a horizontal line, and all horizontal lines are written y equals b, in this case h equals 5. So I'm just going to remind you in your note, it's always a horizontal line. That's what we're asking for when we ask for the equation of the axis. All right, so I'm just going to draw a horizontal line right through the middle of my graph at 5, right here, okay? So that also gives me the middle of my wheel, the center of my wheel, right? H equals 5. So there's the center of that wheel. All right, the next thing we want to find is called the amplitude. Now again, this one's so simple we could just count it on our graph and figure it out pretty quickly. But the amplitude is half the distance between the maximum and minimum values. It's also the vertical distance from the function's axis. So what does that mean, right? It means it's this right here from here to here, right? What's half of the graph basically? That's your amplitude. Now, the equation, if you ever need it, we usually generally just use A for amplitude. You could use a different letter also, but remember how A is also part of our transformations we use, because this is the same A, which I'll show you later. A equals maximum minus minimum. So let's just take the biggest number, subtract the smallest number, and then divide by 2. Pretty similar to the other formula, right? So 9 minus 1 is 8. 8 divided by 2 is 4. In this case, we're talking about 4 millimeters. So the distance from the middle to the top or the middle to the bottom is 4 centimeters. Now, what is this also? This is important because with wheels, and this is something you want to keep in mind when you do your work, okay? With wheels, and any kind of spinning thing like a wheel, the amplitude is also the radius. Okay, so the amplitude is the radius of your wheel. So that's important to keep in mind. All right, so we're going to study these kind of graphs a little more, but let's just think before we move on about the motion of this graph. So think about it. Let's just think of a point on this graph. I'm going to start there at the bottom. Okay, and let's think as it rotates around. You know what? I'm going to get rid of a lot of this extra stuff here too before I get into this. Let's just erase this and just think of this wheel again. Okay, so we got our wheel. There's the middle of it right here, and it's rotating. So let's just say it's rotating this way right here, right? So let's start here, and we're going to start rotating this way. So think what would happen. We start at the bottom. That's this point right here. As it rotates upwards, right? Let's just think it gets to this point here, halfway up. That's right there. And then it keeps going. It gets to the top. That's right here. And then it starts to rotate down, right? Rotates down. That would be right there. And then it gets back to the bottom again, right here. So they didn't ask us for the period of this function, but the period of this function is 0.25 seconds, right? So a quarter of a second, right? That's how long it takes to do one cycle. One cycle of a wheel is one rotation, okay? So let's make note of that too, right? Because that's going to be very important with some of the homework questions you're trying, okay? Is equal to one rotation of the circle, okay? Keep that in mind, because as the wheel goes up and down, that's one of them, and then it repeats over and over and over again. And like I said, all wheels make the same smooth curve, smooth wave, and we actually call this a sinusoidal function, which we'll investigate a little more later. But they all make this exact same smooth wave. All right, let's move on with a little more here. All right. Okay, rolling along, looking at example 3. We're just going to look at 3 more examples from your textbook. Just kind of looking at scenarios that can be periodic, which means they repeat, right? So another one is the daylight hours. This is a really good one, right? So this shows the average number of hours of daylight over a 3-year period, right? So over 3 years. Now, 3-year period can be confusing because the word period, we think of time. When we talk about the period of this, that's only 1 year. Oops. Oh boy. There we go. So 1 year, right? So 1 year, we would cut it off right here at 365 days. There's one period. So the period of this would be 365 days for one cycle. Cycle and period, I guess, are a little interchangeable, but the word cycle really refers to this here, right? The actual graph. There's one cycle. The period refers to the amount of time or your x value. So the period would be 365 days for one cycle. Excuse me, one cycle. I really gotta get a pause button here or a cough button, you know? Okay, so, sorry, what was I saying here? The period is 365 days. Now, the equation of the axis, right? And again, let's just review this again before I get going. The amount of daylight hours, right? As the year goes on, as our Earth rotates, right, around the sun, and as it rotates on its axis, you know, we have less daylight in the winter and more daylight in the summer, right? So that's why this graph makes this. All right, so anyways, I'm rambling, sorry. All right, the equation of the axis. Let's just use y here. The axis is the middle. So how do we do that? We just add the peak and the trough. So they're saying a peak of 18 hours, a trough of 6 hours, and you divide it by 2. So 18 plus 6 would be 24 divided by 2. It'd be 12. So again, remember, this is a horizontal line. So this would be the middle right here. This would be the line y equals 12 if we were going to label our graph. The amplitude, on the other hand, is, remember, the radius of our circle, or in this case, we can also just say what is the distance from the equation of the axis to the top, or the distance to the bottom. It's the same thing. And if you need an equation for that, y equals, we just subtract the two numbers and divide by 2. All right, so we end up getting y equals 6 hours. Okay, so the amplitude is a number, right, relating to the units of the dependent variable, the y variable, so 6 hours. The equation of the axis is that horizontal line that shows us the middle or the center of our graph. All right, the next one, a piston. A piston is an important part of a gas-driven engine. So a piston generally has these up and down movements. We won't bore you too much on the details, right? But you can see this piston's going up, and then up even more, and then down. And then it repeats. So right there, look at, there's one period. There's one section of it, right? One cycle. The period is the amount of time that it takes. So period in this case is 6 seconds for this piston to go through its entire cycle. And then it repeats. And then again, let's just do the old equations here, right? The axis, what's the top plus the bottom? So what is 1 plus -6 divided by 2? And I get -2.5. And again, that's a horizontal line. So I'm just going to do a real quick, not the greatest job here. What do I have it at? -2.5. So it'd be right kind of in between there. I think I'm drawing the right place because that's 2, 2.5. Yep. All right. So there would be the halfway point. And what's the amplitude? Same thing, except we're going to add and we're going to subtract the peak and trough. Sorry, I'm really losing my mind here. There we go. All right, so 1 minus -6, that's 7. 7 divided by 2 is 3.5 centimeters. So that would be the distance, right, from here to here, or from here to here. Okay. Final one here, and then I just want to talk about one more quick example, is this one here. Now this is non-periodic. This is where people start getting tricked. It does not repeat the same thing over and over again. Yeah, there's a pattern to it, no doubt. There's lots of patterns, but is it doing the same thing over and over again? You should be able to take a piece of a graph, right? Like I should be able to come over here, and I'm gonna get my little copier out. Look, I should be able to take this right here, and I'm just gonna paste it somewhere here. Give me a second. I'm making a real sloppy mess. There it is. And I should be able to just like lay it right over top somewhere else, like here, or lay it over top right there, or lay it over top right there, and it should fit right in. So you should be able to take that one cycle and copy and paste it, right, to continue. If I do that here, and I'm sure, oops, I've made everything disappear. If I do this here, and I'm sure you can all see it, but I just love droning on. If I take this here, let me just paste it somewhere, and I copy and paste it, it does not match, right? The graph keeps getting higher, a peak and a lower trough. It keeps changing. So this is not periodic. It is a function for sure. Oops. But it's not a periodic function. So we're not interested in these right now. We can't find the period to it because the period is how long does it take to repeat. It never repeats. It just keeps going. Now maybe they cut it off here. Maybe they take that whole thing there and then they copy and paste it, but we don't know. And I'm not feeding you trick questions or anything here. So let's not assume everything's a trick. But we could make it periodic if I did this and then I stick that onto there, right? And I just keep copying and pasting this thing. Right? Okay, now I've made it a periodic function, right? But the one on the graph is not periodic. Man, I keep deleting the whole page here. All right, so it's not periodic. Let's not worry about peak, amplitude, any of that stuff. All right, I just want to look at one more example right here. This is one I'm going to give you guys for homework, where I want you to sketch your own graph, and you're going to get to make one up. And you don't have to be super creative or artsy or anything, or really have deep knowledge here. The idea is I just want to make sure you understand what these definitions mean and where they'd go on a graph. So it's one thing to look at one, but can you make one? So let's start with this. Now, what you draw is kind of up to you. We can repeat whatever we want, but let's focus on the numbers here first. All right, sketch a graph of a period function, a periodic function. I got the wrong word there. Periodic function with a period of 30. So that means every 30 whatever, right? So let's make this is our y-axis, this is our x-axis. So here's what I'm going to do. I'm going to go, all right, I'm going to make this my first period. There's 30, right? I'm going to start at 0. Now you don't have to start at 0. You can start at something else, but I'm going to keep this as easy as I can. It's going to start at 0, 30, 60, right? The next one will occur at 90, and so on and so forth. Okay, so I'm keeping it pretty simple. We don't have to get super detailed with our graph here. All right, it has an amplitude of 8 and whose equation of the axis is y equals 5. All right, so let's focus on that equation of the axis for a minute. That means the middle of my graph is at 5. So I'm just going to kind of go over here and just go 1, 2, 3, 4, 5. We'll say that's where that is. Well, maybe we better make it a little smaller because I'm looking at that amplitude. It's not going to fit in too well. Let's just 1, 2, 3, 4, 5. All right, we're going to say that's where 5 is right there. All right, so again, you can kind of just sketch this with a ruler. You don't have to get out grid paper to do all this. Just get out your ruler, make a little sketch like I'm doing here. All right, so I'm going to draw in the equation of the axis, which is always a good idea. I'm a little bit off there, but you get the point. We'll just say that's where 5 is. It's hard to get this thing to line up. I know you're having such a fun time listening to me drone on while I fiddle with this here. Okay, let's label that y equals 5. So that's the middle of our graph. Now, the amplitude is 8, right? So that means we have to go 8 up from 5 and 8 down from 5 to find our peak and trough. So let's go 5 plus 8, right? Which would give us 13. So 5, 6, 7, 8, 9, 10, 11, 12, 13. We'll say that's where 13 is. And let's go down 8 from 5. So 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3. So that's where our peak and trough are. And I'm also going to draw a little line in there for those. Just so it's easier to identify them when I draw my periodic function so I don't run into any trouble. All right, so there's that, the best I can get it. And there's that, pretty good. All right, the lines are a little bit skewed, but they're not too bad. Okay, so we've got basically everything we need, and I haven't even thought about how to draw my function. That's the secret of this question. People draw the function first, and then they try to fill in all the lines, and it makes a mess. So we want to do the opposite. Draw all your lines in where we want it. In fact, you can even let's just put a dashed line in here, just showing where one cycle of our period should be like that, right? Here's the second cycle and the third cycle and so on and so forth. Now, what you draw in here doesn't matter, right? As long as it hits a high point of here, hits a low point of there, and it repeats. So I can just do something silly, like I'm gonna start right on 5 and go, up, down a little bit, then I'm gonna touch my peak, then I'm gonna touch my bottom, and then I'm gonna come back. Now, all I gotta do is try to do my best job to repeat that again, where I go up, down a little bit, touch my peak, touch my bottom, come back, right? That's not perfect. That's why maybe I should have chosen something a little simpler. And then let's do one more of it, right? And it just keeps repeating this cycle. Now again, that one's a little sloppy, but you get the point. I'm just repeating there's one period, right? So there's an example of a periodic function. Let me just undo all this. And let's do another one. Again, it can be whatever you want, really. Let's just use maybe straight lines, but it'd take a while. So I might use my ruler. I might go, okay, up to the top. You don't even have to start at 0. You can start wherever you want. I'm just using 0 because it's easier. So start at 0, and then I'm gonna touch the bottom, and then I'm gonna come back again. Almost. There we go. There's one. All right, let's do another one. Up to the top, down the bottom, back again, and so on and so forth. Up to the top, down the bottom, and back again. I'm repeating. Now, it's not perfect because I'm just kind of freehanding this, but you get the point, right? There's one period, 30 seconds, right? And one cycle. So there you go. The period is 30 seconds or 30 whatever. In this case, it doesn't say what the units are, but mostly when we do real world ones, it's time. And you just repeat, okay? So when you make one yourself, take what I did and start by not drawing the graph, but draw all these lines first. Where does it need to be? That's really showing that you understand it. And then you can kind of draw whatever the heck you want. Could be even something really simple. I don't know. Here's a wavy line, up, down. But we got to make sure it hits the peak and trough, right? Wavy line, up, down, like a EKG reading, right? Wavy line, up, down, right? And then it continues on, right? So there's another one, okay? All right, so good luck on that. Watch the other videos and keep in touch.